A very good morning to all of you. Hope you guys are enjoying your weekend and something new this weekend. Okay, so we have done a web session last week, I guess, and this time we got lots of requests for WebVR, and we actually have a best person to understand WebVR from very scratch. So if you guys are thinking it's gonna be a problem, so don't worry. We are going to cover it from scratch. So introducing Shubham Kumar. So he is in fourth year currently and he is in KIT and
Hello, I think we lost Pradyum. So, so hi everyone. As you can see, uh, we are live for the sessions on WebVR, AFrame. Uh, and on today's session, we let's just start with what we are gonna learn. Like today's session is just about introduction to VR, WebVR, and 3D computer graphics. Okay, so we have some people. Okay, yeah, nice. Okay, so yeah, this is like the basics of what we are going to do today. We are going to do, yeah, I think Pradyum is back. Let's see. Okay, so a little bit about myself. Uh, I am Shubham. I am in fourth year KIIT studying computer science, and I love VR. That's it. That's the reason why I thought like doing these sessions, that would be great to just share with you people and just learn from you too. So that would be amazing. Now, okay, let's just see. Let me just do one thing. Let me share the screen that I can tell you what we are going to uh, like see and learn, because it's a two session program. Today is the introduction, and tomorrow, that is Sunday, it's the main hands-on session. So uh, if you guys uh, can make it, that tomorrow is like the best date for this session, because you learn to do WebVR, you learn to create your own scene. And let's just show what scene we want to do. Okay. Mm, all right. So I hope you guys can see. Can someone just tell me that it's visible, like from the team or anyone, like this lighthouse scene on any like WhatsApp or something, or
it's surely visible. Yeah.
okay. So this is the scene that we are going to do tomorrow. We we learn how to import models. This is a very low poly scene. It's just for demonstration purposes, but you can do most of the just learn. This is the basics. Just learn it, and you'll be able to do like most of the things that you want to do, because most of the time you are just importing things and placing in VR. That's the basics of it. That's how you create a scene in VR. You and right now we are in the phase where VR is not like that much advanced on graphics. field, so we are working with like low poly stuff. So less number of you can say polygons. If you are a 3D modeler or game developer, you would understand like what low poly means. But what it basically means is that look at this, like these models. If we look at these, you can see there's like yeah, there's jagged lines. There's so much less segmentation. Like there's such less amount of detail in the model that that makes it low poly. I mean, let the light hit it. Like yes, you can see there's so much big triangles and squares here that make up this model. So that is low poly, basically. Less number of details in the model. So that's what we are going to import like tomorrow. That's what we are going to build. And if you are wondering what is this, like on top left on my screen, this is just stats which shows like how much like this scene is like performing. What's the details of this scene? So there's frame rate, there's the ref number, or ref, yes, yeah. So that is the latency between frames. There's this 3js and all that. We'll talk about that like later, what everything means and how we can optimize our scene. So this is the scene basically. You'll be seeing this ocean, there's fog. So when you like go on a distance, you can see the fog and there's light rotating it, and then there's this. So this would be the scene that we'll be making. We can add our more let's say we can improvise on it. So yeah, this is the scene. Everything, every model, every code that you want uh, would be provided to you. Like it's in the GitHub repository. I'll be posting it. So this would be provided to you. That's the basic scene that we are going to make. And don't worry, that's very less amount of code. 62 lines. You can see, but any kind of framework, like even though it's 62 lines of code, any kind of framework, you need to understand how that framework works, how everything in that let's say framework or anything entity component system, whatever it is, how it works. We need to know that. So that's what we are going to talk about like tomorrow, how how we are going to set up every single thing, like set up our scene from scratch. So that's, and for today, let me see, let's stop the screen sharing. So for today, we'll be going to learn about the introduction to VR and 3D computer graphics and all. Like what are the terminologies used, and how you can actually understand like how these things work. Because having some background knowledge on this field or any field, that's important, because that's the main reason like you should be learning something new. I mean, you can build anything with just knowledge of like a week, but if you have some ground knowledge, some in-depth knowledge, that would be great. Like then you can do something that no one has ever done. So aspire to be that person. So, yeah. Okay, so uh, okay, so how many people that we have here? Like, can we just start with this? Like, uh, are you guys like interested in this, or you want to introduce yourself, or anything if you want to do, or if you just want to carry on with the session and just start with the intro part of the VR? I mean, if you guys have anything you want to tell or show us, you can tell me in the comment sections. And yeah, so while that happens, let me set up the uh, PDF for this. And yeah, one more thing about like the question answer session. If you have anything like any doubt, you can just post it in the comments. Like it should be like back and forth, like spontaneous. I don't have I didn't plan for any question answer sessions like at the end or in the middle or something. So if you have anything, you can do it. Oh, hi. There's one guy who said, yeah, hi, Dattu. So yeah, this is good. And yeah, let's see. Anything else? Like if you guys have anything, and yeah, we talked about question. Like if you have any question, just ask it in the uh, comment section. Mm. All right. So I guess let's start with the PDF. Let me share the screen. Okay. All right. So is the PDF visible? Let's start with the session, like intro, without any. Yes, I guess it is. All right. So let's just start with like what is virtual reality. Let's talk about session is about. That's what the session is about. But yeah. So uh, the very first question that comes to mind is like, how do you really define virtual reality? Let's hope that you guys can see it. I'll be posting this PDF in GitHub repository, and we'll give you the link soon, just like in last minutes of this session, so that you can just go back and revise or something. Okay. So yeah. So what is virtual reality? How do we actually define what virtual reality actually is? So it is actually a very huge field of computer science, and for if you want to, let's see. Okay. So, okay. It is a very like, huge field of computer science and also computer graphics, but uh, if you just like if you want to define it for in like layman terms to people to understand, virtual reality then is basically computer generated immersive experiences. That's it. Like the that's the definition of it. Virtual reality is basically computer generated immersive experiences. It consists of two words like virtual and reality. Virtual is the computer generated part, anything that does not exist but is still like make it visible. Like we created using some concept, some softwares or anything. So that virtual part is this computer generated. That's the virtual uh, part of that term means, that phrase means. And reality is actually the immersive experiences. If we talk about our reality, which some of you might think that we are still in a simulation. So if we think about it like that, that's also an experience which is immersive. We are in this reality. We can feel it. We can perceive it. If we can interact with objects. So that's how our reality works. We can see it all around us. We can feel it, and we can interact with it. That's why it's a reality. And uh, when it is computer generated, it's virtual reality. So that's what it is. Virtual reality is basically computer generated immersive experiences, which can also be interacted with using some computer graphics or mathematics, like concept of these, and yeah, definitely high performance computer hardware. So And there's also other things which which constitute or which has similar meaning, or people tend to use them like alongside each other, is these three: augmented reality, mixed reality, extended reality, all that. Augmented reality is basically taking some computer generated images or 3D models or anything and putting it alongside you, like in VFX. What they do is they shoot some scene, and they just overlay other it's a computer generated or other computer generated imagery, that is CGI, on top of that film, or on top of that uh, the scene. That's how like VFX works. And in AR, that is happening real time, and that is not VFX is not real time. They have captured everything, they have made everything, and that's just another phase. That's like layering on top of one another, layering one scene over other, and then other, then other, so it makes it look like that real, but it's not real. And augmented reality is doing the same but real time. So let's say you use filters or anything in your phone, something like that. So if you use those, that's augmented reality. So, oh, I think there's background noises. Sorry for that. But so yeah, that's augmented reality. It is layering another level of reality on top of our like current reality. So that's how it works. And for this, like if you want in detail, Pradyumna is the guy. Like he did the WebAR sessions and all. So you can just look at those sessions if you want to learn about AR. And then there's mixed reality, where uh, these things are like mixed and extended. These are like uh, more advanced versions of virtual and augmented reality. They you can like uh, understand from the term like mixed is just you mixing those computer generated realities with our current reality. And extended reality is just extending our reality so that it looks even more better. It's like VFX in real life. That could be amazing, right? Like there's more definition on it on the internet and on the web. You can just uh, Google it and search it, so you can find more in detail about it. But not to go sidetrack, we are just focusing on virtual reality, so that's why. Okay, so the obvious question after this would be, uh, when was it invented, right? When was it uh, when it all started? That's the thing, right? Everything has a starting point. Computers started in some ages when Alan Turing and all, they developed some machineries and all that. So everything started. So when VR started, so that's the question. But before that, like if let me stop the screen sharing. If you guys have anything regarding the intro to VR, like any questions or something, if you have it, you can just tell me anything. Like up to this, it's clear, right? It was not much, but still. Now you can define virtual reality as immersive computer generated experiences. You can write in comments if you could, or we'll just go ahead in like 30 seconds. Let me wait. Let me set up that. Okay. All right. So let's start. Um, yeah, yeah, okay. So here we have it. The next question that is, well, then when was it invented? Everything has a starting point. So, what was the starting point for VR? Like when virtual reality started? What was its time? So we can see like it started in late 1960s. The starting point of it, where we actually got the chance to see the first, you can see in 1968, first head mounted display was built. That was the start of it in 1968. You can see that after 1 year, uh, man went to moon. But before that, VR started. VR actually had its first head-mounted display. Now, what's head-mounted display is, you guys might have noticed, like these things which you wear on your head, on your uh, head, which has these two lenses and all the fancy tech to actually make these virtual reality possible. These are those devices. This is head mounted displays, and this is another type of display. We'll talk about it later. So yeah, that's the history of it. It started in late 1960s, and that was the time, like 1968, where first head mounted display was built. So yeah, it is like 6 decades old. But if you talk about the concept of it, like that, 1968 was the time where uh, it was built. Like there was some evidence, like the first ever hardware to fully utilize the power of virtual reality. That was that time. But uh, the concept of this, like virtual reality and all that, that was before 1968. It was even before, I think. The first was about 30 or 40 years, like the paper or something, like there was only theory of it. But after that, that's the main implementation. Uh, that's the main engineering, let's say, masterpiece or achievement that we had built, first head mounted display. And it has traveled a long way, uh, definitely a long way to come to us in the, like where we can just use it on our phone, which which is just crazy. You can just mount your phone on some display like this Google Cardboard or something. It's very affordable. It's 10 or $20, I guess, and you can just convert it into Indian rupees. That's not much. So you can just use this, and you can experience like this Google Cardboard, and you can experience virtual reality. That's how easy it is to experience it. Now, when you want to go for some PC based or standalone uh, these virtual reality headsets, you have to pay more, because it's a very high tech, it's a very advanced hardware that we are talking about. And if we connect it to sorry, if we connect it to PC, it gets really advanced. It needs some advanced architecture to run that softwares. Why it requires such advanced hardware? That could be a question, right? Like that's a valid question. Why does it require such an advanced hardware to run? The basic answer would be how it is rendered, how virtual reality is rendered. That should be basic explanation to it. Uh, if you guys have played games, which you might already have, everyone, so in game, uh, how they render is, you have a screen, and that screen is basically your camera. That screen is what you're looking at. So everything that camera can see, they render it like pixel by pixel, and there's so much pixel. If there's like 1920 into or 1916 to 1080, that's the resolution of your screen. You multiply that, and that much pixels are there on your screen, and that's that much pixel every time they have to render for let's say 30 frames per second. If we say 30 frames per second, that is that those frames, or frame is basically you can say image. When you capture some image on your camera, uh, when there is like in our reality, when we capture some image, that's just a snapshot of that current time, right? In this, and it's stored. So that is frame. And when we use video, when we do videography or anything, what we are actually doing is just capturing those frame at a certain frame rate, that is, let's say 24 frame rate per second. In that's the classic cinematic frame rate, 24 frames per second. So when we are doing this, we are basically taking 24 pictures in a second. That's what 24 frames per second, fps, means. So in games, we are rendering that. We talked about like 30 frames per second, right? So in games, we are rendering uh, 30 frames or 30 images that the camera can see. Whenever we move your camera, whenever you move your camera or just place it stable, even though it's rendering that many amount of frames per second, for 30 frames per second, it's rendering 30 images. And that too, pixel by pixel. Each pixel has to be calculated individually, and every pixel has some latency, some time to be calculated. Now with such advanced computer graphics hardwares and computer hardwares and such advanced computer graphics software, optimized algorithms, that can be done like very easily. But let's keep it on the surface, because this could go very much theoretical, and it could be hard for absolute beginners. And so let's just focus on how rendering in virtual reality and games differ. Now rendering, if you're wondering, if you heard it first time, or you if you have heard it and don't know what it actually means, rendering is basically showing the results. That's the easiest way I think I can explain it to you right now. That's how you take video. This is your camera, and you take video. So that is actually doing capturing those capturing the uh, actual world or reality, and uh, just making a file which is let's say 24 frames per second or anything. So that file is actually the video, and that is the collection of rendered image at a certain frame rate. So rendering is in easiest terms is just showing you uh, the end result of any time. Like and if you take a snapshot of this, like if you take just a screenshot of it, it is just uh, it's a rendered reality. Uh, it is just a screenshot, or it is just a simple snapshot of anything at a particular time. So that is rendering. It is just showing you the end result, basically. So uh, now how games work is basic. It's just they they render, or they show you the results uh, at a certain frame rate. So if you move your camera, now everything has to change. Like everything has to be redone. So that is how game happens. And in game, there's only one camera, and there's other things that goes into uh, games, is that you don't have to actually interact with the objects that are like in the game. You can use other hardwares like computer or mouse or something. You can use keys to interact with them, and then just you hit something, let's say enter the car. For E to enter car, press E to enter car, and you press E, and the animation plays and you enter the car. That's what happens in game. But in VR, you are actually moving your hands, and you are actually relocating yourself to the car to actually interact with the door. So there's no such animations or so. There's so much more calculation in VR that it makes it so heavy, and it for the computer to actually process it. Because when you start doing it, uh, the rendering part, what you do is in VR, you are basically rendering two different cameras every single time. Like in games, there was only one camera, right? There was only one camera that was in our example was rendering 30 frames every second. That was capturing 30 images every second, like 30 images every second. That was what our game camera was doing. In VR camera, we have two eyes, right? So, and if you notice, like you might have noticed and you might have known that the difference between our eyes is about 63 to 65 millimeters. So that's the distance between our eyes, and that's the reason why we need two cameras. That is, we need two cameras, one for each eye. That's why two cameras are rendering your scene uh, like every every second at some frame rate. And for the advised frame rate for virtual reality is 60 to 90 frame rates per second. If you can do that better, like if you can reach above 120, that's the best thing. Like uh, the more fluid the experience would be, the better it is for the user. Now, why we need 60 frames or 90 frames per second, that we'll talk about just in a minute. But that's how it is done. Like if you want to experiment with it, you can just close one eye like this, and you can point your finger out and you can watch it, or just use a pencil, and then close the other eye and watch the same finger. And if you do that repeatedly, like blinking or just um, closing one eye and then the other, one eye and then the other, you can see there's a possible shift uh, in the, like, you can see the image is shifted somewhat. And that's how virtual reality is rendered. Our brain actually uses this technique. It takes two images, one from the left eye and one from the right eye, and it superimposes them in such a way that it resembles to be one single image. That's how our brain is working. That's our brain is doing stuff. And that is the same concept we use in virtual reality. We do two renders every frame. So at that time it was just one render a frame, like in game. And in virtual reality there's two render, and one is, let's say one is at this point, so the other would be about 65 shifted. So that's how the frame is rendered. So when we render everything twice every frame, and the frame rate should be about 60 to 90 frames rate per second, that is twice or thrice the required frame rate for a game, you can see that it's like increased the complexity of the game by like amount of 3 times. So when you just increase that rendering complexity about 3 times, you have to compromise somewhere, and that's where we compromise with uh, the graphics, the low poly graphics. That's where these low poly scenes come into play. We we use less detailed models just to compensate with that. If we have if we have high details model in virtual reality, one thing would happen, that anything, if you have, let's say, high graphics game on a low end PC or low end console which can't render that fast, you can see there's possibly a lag, and that um, slow rendering, that is basically, you can see like every frame there's some lagging, and uh, you have to just use your setting to just put it down, or just keep a low setting just to play that game. So that's what happens those uh, in those games. So when we increase graphics in virtual reality, the same thing happens, because it's the same thing, right? It's basically a game which has two cameras and some better interaction methods. So when this happens, uh, your system lags, and there's latency, there's increases, that is every frame, it takes some time to render one frame and the other. And as this system slows down, you would feel motion sickness, and you would want to throw up, and that's a really bad thing. Like, we talked about the cinematic frame rates, right? 24 frames per second. So when we change that frame rate, we feel a strange, let's say, there's a strange feeling that okay, something's not right if we increase that frame rate. So uh, let's take an example. They did that in Lord of the Rings. Yes, they increased the frame rate from 24 frames per second to 48 frames per second. And even though it was a 3 hour movie, the audience could uh, th- they can just tell that something's not right. The moments are more fluent, they are more fast. We can't just connect to it, because we are so accustomed to the 24 frame rates per second, uh, that's a frame rate. So if we change it, we feel off, and that's what happens in reality. That the opposite happens. So we are accustomed to such high frame rates that every motion is so fluid. And when you just place your head mounted display, or you just go into a virtual reality environment, and you have a low frame rate experience, you would think that okay, reality is just something happened. Reality is not this, like, and then you will feel motion sickness, and you might throw up, or just pass out. That can happen. So that could be a really great way to take revenge on your ex if you want to do that, but do not do that, because that's sick. And yeah, so uh, and yeah, the frame rate that we were talking about, why 60 frames per second, why 90 frames per second, why 120 and above is better and best right now. So the the idea is to match the frame rates of reality. How much frame rate it is, I don't know, man. But it is very high. uh, Everything that we see, we perceive, that has very high detail, and a very fluent are in very fluent motion. So if we don't match that, then we will just make the user, or any kind of experience, just bad for our health and their health. So, and uh, why 120 frames per second and above is better and best is actually, uh, the more fluent anything is, the more in VR headset, you don't actually feel off. You feel that okay, this is good. Like there's no, I can you can actually relate to it. You can actually think that okay, that's something that can happen in reality, and that's what happens. You must have seen those videos where people wear headsets in mall or any places or home, and they get like amazed, scared, or just uh, shocked by something that happens in VR. That is because they are immersed in it and they can feel it. They can see, okay, that could happen. That could really happen in reality. Like in a game which is of genre, let's say horror game, people can just get scared of it when something uh, flows by them or just comes towards them at a frame rate which is high, because they they can't register it. They would just feel like, okay, it's reality, and that's the essence of it, right? Virtual reality, creating reality that feels real but it is not real. that would be that would be the best like experience for that. So try to aim for higher frame rates. And I know most of the computers and phone, even my phone is just 60 frame rates per second. And um, which is not good for virtual reality, I would say. That is like bare minimum. So don't go for the bare minimum. Try to have it, try to achieve uh, better frame rates. And if you can have those hardwares that can help you do that, just like upgrade your hardwares. And if you can do that, that's great. Even if you can't, it's okay. All you have to do is to just create experiences, and people with those hardware, they can experience it, and even you can experience it. That's what this session is about. And why we are talking about like these theories in such like details is that, believe it or not, user experience in VR is critical. If you do one thing wrong, you can just throw that user away from the cliff. Like he or she would never come back to VR just because of one mistake. One time they throw up or one time they pass out in VR headsets, it's it. Like that's it. They are never coming back for that. So it's better to take all these precautions. It's better to do all these stuff where you can actually do uh, mm, let's say when you can actually perform better. So why not do that? I mean, why make them suffer? Oh yeah. So let's talk about, oh, is that some, okay, okay, no. So let's talk about some applications. These are like, the list is very huge, but these are very common, and I think it's about time that we ended like the sessions. And if you have questions, I thought I had it. Okay, okay. There's some very, yeah. There's a team working behind. That's great. So okay, so the application is just entertainment, that games and movies, videos. You can watch those in VR, which would be great. And yes, if you have something that you want to watch in 3D and you don't have those 3D glasses, you can watch it in VR. Just use this, pop your phone in the and any kind of VR headset, or connect your PC VR headset and just pop it in, and you can watch that in 3D too. That's a real benefit for that. Like these headsets and all, you can watch 3D even if you don't have those glasses. And yes, that the video or anything that you want to watch in 3D is actually 180 degree or 360-degree, basically stereoscopy and equitriangular. That's the term that is used for the files that are compatible with VR. And you don't have to know about it. Just look for these terms if you want to watch any video or anything in VR. So, okay, so that is the entertainment, games and all simulation software uh, that is used in NASA and any kind of medical training program. Those are the simulation softwares. Uh, Healthcare, yeah, definitely healthcare. You can actually learn more in depth about all those things that you can't see. You can actually experience those in VR, which is great. Then education, you might have guessed that, like, you can basically create a software that looks like Jarvis, and you can teach people that, okay, this happens, and like Pythagoras theorem and all that, volumes and surface area and all that. I don't know, like the possibilities are just endless. Then there's design and engineering, which you can guess by how good this thing can be. Actually, you can actually create virtual worlds using VR. The latest movie, what was the name? Lion King, that was made in 3D. That was actually a product of virtual production. So the people who were working for Disney at that time were given VR headsets and all that, controllers and all, and they were placing those objects in that world itself. So the cave or the any kind of world that they were creating, they were making that in VR. So they were given all the tools and headsets and all, and they were just placing those objects using the controllers and things. So that can be a very good explanation of it. And there's other like architecture and all. Okay, battery is about to die, but okay. So, and then there's the type of devices. With this one, you guys are known to, like, you know these devices. This is a cave. Now, what is a cave? So let's just see what is a cave. Here, let me show you. Yes, cave automatic virtual environment. This is basically like a room with walls, which and there's many projectors around you. Is like in different on different angles that projects these images, which looks like that you are actually in that environment. You are put into a room with projectors and cameras and all, and they track your movement, and uh, they project that according to where are you looking. So if you are looking at this and you just turn around, so now the image that was behind you will be projected here. So that's what cave is. This is more of a like extremely high end, that is used for experimental purposes and all. That's not very much available to user, but these are, so you can use this. And that's about it. Like, yeah, okay, that's about it. Let me share, stop this, and I'll be posting this on GitHub, like we said.
Okay, so good morning, everyone. So there's another Shubham on the stream right now. So yeah, so I'm technically the host. Please don't mic yourself, sir. So yeah, I think we can proceed forward with the Q&A session right now.
Okay, like if you guys have anything, you can ask me, or
Yeah, please.
it's okay. I mean,
Okay, so we'll wait for some 1 or 2 minutes so that if anyone from the audience wants to ask us any questions in the live chat, we'll be able to. So, can you tell me how did this interest for VR grow for you?
oh, for me,
Yeah.
uh, actually, like uh, the very first thing was that I was very inclined towards these kind of uh, like activities. I'm not a gamer, so don't think that uh, just
Okay.
because I play games, I think that keeping or making it like up a notch would do that. But no, that was not the point. So uh, like these, the ability to create a virtual world around you yourself and actually interact with it, that was the kind of thing that made me just go like, Man, this thing is crazy. This is just out of the world kind of thing." And basically uh, any Marvel fan would think of it is that that's just a personal Jarvis, if you think, because everyone loves that. So you can actually
Yeah,
interact
okay.
with it. You can actually tell them to do anything, and they would just. like those objects would do it, and you can create like a virtual environment for yourself and any other person. And that's what I love doing, like, creating experiences. That's what like um, drives me to it.
Okay. Well, that's certainly a very beautiful way to approach what you're doing. And so it's been a while, and I think we are done for today's session.
Yeah,
Thank you, Shubham. Thank you very much for being such an insightful and patient person, introducing all of us to Web AR. And I think tomorrow we'll be proceeding forward with A-frames. Is that correct?
yeah, yeah. Tomorrow is the
Yeah.
hands-on.
So
Today was
so
the
tomorrow we'll be having the hands-on A-frame webinar from 11 a.m. That is 30th August 2020, 11 a.m. So stay tuned, guys, and like, share, and subscribe to DSC Kit. Thank you, everyone.
thank you, everyone.